Okay. In part one, we talked about, we proved the vertical angles theorem. If you look right behind me, we proved that because angles 1 and 2 are supplementary, so are angles 2 and 3. Since they're both supplementary to angle 2, then that means that angle 1 and 2 have to be congruent to each other by definition of congruence. So that was the vertical angles theorem. Now remember, a theorem is a statement that can be proven, and we can prove it using postulates or previously proven theorems. So now we can use vertical theorem 2-1 to prove future theorems after that, which we actually use it to prove theorem 2-2. We're not going to do that today, and theorem 2-3. But let's talk about those. Theorem 2-2 is the congruent supplements theorem. The congruent supplement theorem says if two angles are supplements of the same angle, then they are congruent. So right here, angles 2 and 3 are both supplementary with angle 2. So therefore, angle 1 is congruent to angle 3 because both supplements to angle 2. And the same thing goes down here with congruent complements theorem. It says that if two angles are complements of the same angle, then both angles are congruent. So that means that angle 1 or angle 4 is congruent to angle 6, and both right today. Oops. Both complementary to angle 5. And we would use we could even use the vertical angle theorem to prove those, but we're not going to right now. You just need to know those. And don't try to memorize them, just know them. All right, theorem 2-4. All right angles are congruent. Just know that all right angles are congruent. I don't remember what theorem number it is. After this lesson, I'll forget it, but I will know that all right angles are congruent. And also, if two angles are congruent and supplementary, then each is a right angle. We could prove that, but we're not going to. So basically, if angles 1 and 2 are congruent and supplementary, then that means that they're both right angles. We could prove that, but we're not going to right now. Just know that if two angles are congruent and supplementary, then they're each right angles. We'll talk more about that as the semester goes on. All right, here we go. Okay, back to some basic algebra. All right, determine the value of x. You don't have to give reasons why. We could, but we're not going to. Here's what we know. We know that these two angles are vertical. If they're vertical, we know that they're congruent. So we said 3x equal to 80 minus x. And we're solving for x, so we add x. So that's 4x equals 80. Addition property of equality, simplify, divide by 4. Division property of equality, and there x equals 20. You don't need to worry about all those reasons. I'm just reminding you of what they are. So this is the kind of stuff you'll be doing in this lesson. So, all right. And feel free to rewind this back if you need to. Okay. Okay, we need to determine the values of x and y. Let's start with x. Okay. 2x and 76. They're vertical. Since they're vertical, we set them equal. So I said 2x equal to 76. Divide by 2 means that x equals 38. All right. Now, y is just a bit different. Y, and so notice I'm using the same angle for the reference. They have different relationships, but they're same. So I got y plus 76. They're supplementary. Y plus 76 equals 180. I'm right there's a supplementary. Up here, these are vertical. So y equals 104. All right. It's kind of stuff you'll be using on your lessons, so stuff you need to be prepared for and stuff you need to know how to do. All right. Now, basically, here's what you have to determine. Before I move on to the next part, you need to know three things. Are the angles vertical? Are they supplementary? Or are they complementary? You got to ask yourself those three questions. Are they vertical? Are they supplementary? Or are they complementary? There you go. Ask yourself those questions. If they're vertical, set them equal. If they're supplementary, add them and set that equal to 180. If they're complementary, add them and set them equal to 90. All right, now, here's what I'm given. I'm given that angle 1 is congruent to angle 3, and I'm trying to prove that angle 6 is congruent to angle 4. That's what I'm trying to prove. Always use your diagram. Give yourself a visual. Give yourself a visual on this, okay? And I'm even going to draw on there that angle 1 is congruent to angle 3. I'm doing those in black, and I'm doing what I'm trying to prove in purple. Okay, now, your diagram is there to aid you. It's there to help you. So here's what I know. I know that angle 1 is vertical with angle 4, so that makes them congruent. So I'm going to do that. And some of this is just trial and error. So I know angle 1 is congruent to angle 4 by vertical angles. Okay, angle 1 and angle 4 are vertical angles. Well, I also know that angle 6 and angle 3 are vertical angles. So angle 3 is congruent to angle 6, also by vertical angles. Okay, now you're probably thinking, do we have to use definition of congruence here? No, we're not dealing with angle measures. We're just dealing with the fact that they're congruent. If we were given actual degree measurements, then we would have to use the definition of congruence. But since we're not, we can simply leave them as congruent. Okay, so here's one thing we know. Okay, angle 1 is congruent to angle 4. Now I'm going to take this statement right here, and I'm going to move it down here, but I'm going to replace 1 with 4. So angle 4, and replace angle 3 with angle 6. And that is by substitution. So I was able to substitute 2 other congruent angles for what I already knew. Now I'm done. I've proven what I need to prove. I'm done. Just 4 steps. And one of those steps was to give it. So, all right. Now, that, ladies and gentlemen, is all of chapter 2. If you have any questions, be sure to email me and let me know. And I will be talking with you again very soon.